So in this video we're going to go over finding and then verifying the inverse of a linear function. So we just did a video on verifying that two generic linear functions were indeed inverses of each other. Now we're going to deal with the case where we find the inverse on our own. In other words, where we've taken a y equals linear function and we solve it for x. And when we do this and we do function composition like we did in the previous video, when we take the inverse function and input it into our original function f of x, the input variable to the inverse function will pop out. And if we take the original function f of x and input it into the inverse function, the input variable x will pop out of the composition process. So let's see how this plays out in practice. So it says for f of x equals negative 3x minus 2, find the inverse. Verify by composition that the function you found is the inverse of f of x. So I have a function f of x. I'm going to replace the f of x with y, right? We're taking a function f that has input x, output y, and we're finding an inverse function that has input y, output x. So to simplify our life, we'll replace f of x with y because in a function context they're synonyms. So we write down our function y equals negative 3x minus 2, and then the inverse we simply get by solving for x. So we do y plus 2 equals negative 3x, and then I'm going to multiply both sides by negative 1/3, the reciprocal of negative 3, so multiply by negative 1/3. Because the product of reciprocals equals 1, this will give me negative 1/3 times negative 3 is just 1 as the coefficient on my x. So x is equal to negative 1/3 y plus 2. So if I haven't made a mistake, this should be the inverse of my original function. So I could even give it the inverse name. I could say, hey, f inverse of y is equal to negative 1/3 of y plus 2. So to verify by inverse, all we need to do is do function composition. We feed the one function into the other. So let's start with the first function, y equals negative 3x minus 2. And x, I've solved for x here. My inverse is x. So if I replace x with this stuff, negative 1/3 of times y plus 2, negative 1/3 of y plus 2, and then I have my minus 2 right here, y should equal this stuff. So in other words, if I put the inverse into my function, I should get y, because I should get the statement y equals y. I should get an identity coming out of this. The denominator didn't write down. So y equals, so I'll distribute negative 3 times negative 1/3 is positive 1. So I get 1 times y plus 2 is just y plus 2. And I still have my minus 2 sitting here. So I get y equals y. And this makes sense because this says if you plug in x, you get y as the output. So what did I do? I plugged in x. And I got y as the output. Y equals y. The output equals the output. And so if we do the composition in the other direction, that means we start with x equals. Our inverse function is x equals negative 1/3 y plus 2. Negative 1/3 y plus 2. And then we need to go into here and say, well, what is y? Well, y is negative 3x minus 2. So I can replace the y with negative 3x minus 2. And I still have the plus 2 sitting there. Equals negative 1/3 times minus 2 plus 2 is 0. So I'm left with negative 3x plus 0 is just negative 3x. And negative 1/3 times negative 3 is 1, and 1 times x is just x. I get x equals x. So the composition process here, I'm saying x is this stuff. if I plug in y, I should get x. And what did I plug in? I plugged in y. So when I plug in y, I should get x. So this is how you verify by compositions that you found the inverse correctly in the case where you found the inverse yourself and you didn't do that textbook move of switching the x and the y, which I think when we're working with application problems causes a lot of headache because students switch x's and y's when you can't do it.